Hello guys, how are you all doing? Can you please write in the chat if the sound is correct and the music, the background music and everything? I can see we are already 8. Also, I'm sorry that my voice is a bit different. I was sick for the past week and that's why I had to reschedule the last webinar to this Saturday. But now I'm a bit better. And how was all of your Christmas and winter holidays? Were you with your family and were you able to learn something new? Perfect, the sound is okay. Not very productive. It's okay. Winter is. Sometimes it's better to disconnect. Okay. We are gonna wait 5 more minutes and see if more people are joining in. Nice that you were able to do some grasshopper exercises. I wish I read more. Potato couch, Maritere. I think you haven't been. Are you doing the grasshopper exercises with the same intensity when you were in Madrid? Yeah, and the thing is, this webinar, I send this webinar link to the new subscribers, and they might, or you might, the future viewers, you might feel that what we are talking, but the first 10 minutes are just like this. And if you really want to watch just the exercise, you can skip to like maybe 10-15 minutes, and you can skip the starting 10-15 minutes and we will dive into exercises. Any more people joining us? Can you write on the chat? Hello Anubin, just right on time. Hello Celine, how are you? Are you joining the webinar for the first time? Celine Oktan. And Ibrahim, hello, where are you from, Ibrahim? We will wait 7 more minutes and start with our exercises. Okay, I hope you like it. I don't know if you were able to watch the previous webinars, Celine, but you can go back to the email and find the links to the previous webinars. We looked at anemone, and yeah, it was cool to see how we can use looping techniques inside Grasshopper. From Jordan, joining through London though. Okay, nice. Bianca, hello, hi there. Where are you from, Bianca? Bianca, is it? Am I saying it correctly? I think. Just a second, I have to reduce some music. Okay, Google, lower the volume, please. From Jordan, okay. Do you guys have previous experience with kangaroo? Or I'm sorry, it's just the trigger how it works. Yeah, whenever you say okay Google, it's almost correctly. Okay, perfect. Trial and error. Okay, so you didn't have like a basis, but I think that's a good way to start. Like you start to fiddle with the components and see what you can make sense. And I have noticed that there are some components where it's really hard to make sense what they want as an input and what they're going to output. And there are components which are really intuitive, and I think it has to also be in part of the designers of the components to make it in such a way that even an amateur or someone who's just starting to learn can grasp just by looking at the component. So that could be in the design of UX UI of components. If I know Andrei Nijur, no, haven't heard of him or her. Although I will go back and check on the internet. I'm from Romania. Okay, start buying books. You were asking Bianca what I am. Smart. 4 more minutes, guys. Sorry. We will start in 5. I think in India it's 9.5. Hello, Mikolaj. Where are you from, Mikolaj? If I'm pronouncing your name correctly. Yeah, there are plugins like Millipede. We are gonna see Millipede in the future webinars, and Millipede, when you download it, it comes with the documentation like the PDF plus example files. So it's really interesting. Like you can use the example files and modify so that you can use it in your own for your own use. For example, the handle that I made in the recent Instagram post. So I recycled the example file and I created my own criteria. So they come sorry. So they come handy a lot. I might lower the volume sometimes, guys, because I have a cough. I don't want you to like get afraid. For the handle, I just used Millipede. There was no Galapagos, neither Kangaroo. Thanks, Mariteri. Aman Sasan. Are you from India, Aman? My name is also Aman. Hello. Ernesto. ¿Qué tal, amigo? Okay, I think we can. What is Galapagos for? Galapagos is an optimization algorithm based upon evolutionary principles. we will see also Galapagos and biomorph in detail in the future webinars. Especially in Galapagos, you can make multiple fitness functions, so you can optimize different goals at the same time. So that's a bit tricky part, but it comes really handy. Hello, Victor. Victor, are you joining for the first time or regarding kangaroo growing curves? Okay. Hello, Navi. How are you doing? Yeah, I think we are probably 17, 18. Okay, perfect. So let's start. Well, myself, Aman, for the new viewers. I'm an industrial designer, but I'm really interested in computation and how we can use computation in industrial design. I think if you see some of the past experiments that I have been doing in Instagram, you kind of get the idea. And this webinar is just to share what I have learned. I'm no expert, but it's just I think it's a good way to engage with the community and see where we can take computation and industrial design together. Yes, I've been familiarizing with you guys, and it's pretty interesting that we get every time we get people from so many different regions and different backgrounds. Especially just now, Hebame 164. Hello, where are you from? If you guys can write it down in the live chat, would be really cool. Also, if you can write your background, if you're from industrial design, if you're from architecture, or doesn't have to do anything with this, you can be from anywhere. And I think Grasshopper is a really flexible tool and can help you program whatever you want to do with it. Again, we would like to start with this. We need to keep practicing. We have to be patient and we have to be persistent. So that's why I think this webinars, if you can do it every 2 weeks, you guys are like always learning a bit about Grasshopper every 2 weeks and then apply it in your design projects. So that would keep you persistent in learning about Grasshopper. Montreal, architecture, Canada, Toronto, structural. Hello, Navan. Yeah, I think Millipede and Caramba is really interesting. I don't know if you have used before, but that would be really interesting. Mikolov, you're from Poland, architecture. Okay, perfect. Okay, so in this webinar, we are gonna see the Kangaroo life physics simulator. And if you guys haven't started, just fire up your Kangaroo and your Grasshopper, sorry. I'm just gonna configure it more or less like that. Perfect. Bifocals. Do you guys have the Rhino 6 or you still have Rhino 5 and have installed the new Kangaroo version? Hello, Sandeep. CAD engineer. Do you guys use Grasshopper for engineering? I mean, in CAD especially, like simulations and analysis, structural analysis. Undergrad architecture. Hello, Harish. Okay, Rhino 6, Rhino 6. If you open your Grasshopper, you should find the Kangaroo 2 tab. If you have it, then I think it's perfect. Yes, that's fine. With Rhino 6, it comes pre-installed. You don't need to worry. If you have Rhino 5, just make sure you have Kangaroo 2. It's the same as Kangaroo 1. They just simplified a few components. Okay, perfect. So let's start by doing some really basic stuff in Kangaroo. Yeah, Grasshopper is available on Mac on Rhino 6. It comes pre-installed. Okay, let's start by importing the solver. So this part is what calculates the physics of the interaction between the elements that we want to do. So we have a few of these that we are going to use. So right now we are just going to use the bouncy solver, and we will see later where to use the zombie solver and step solvers. So just click on bouncy solver and import the bouncy solver, and let's create a point, maybe like that. Let's import the point. Okay, so we have this point. Now we would like the point to fall down. So how we can do that? So here you can create the physical rules based upon the element. So for example, here when you see it says goal points, so whatever manipulation that we have to do with a point, we can do here. Whatever we have to do with mesh, we can do here. Whatever we have to do with curves, we can do here. And they are just like a simpler version. So for example, you can a mesh is made out of curves, and a curve is made out of points. So it's basically the same. But if you keep using the higher level components, you don't have to calculate each curve and point. I don't know if I'm making sense, but if you're using point, then it's better use the goal from points and so on. Okay, so we have imported the point, and let's use the load component. So it asks me for two things. The first thing is the point. Okay, this is the point. And the force vector, so we want it to go down. So we are gonna create a vector x, y, z. Connect the vector, and in the z vector we would like it to go to -1.00 till maybe 1. We can experiment with it later, and connect it to the goal. As you can see, the point just fell, and I think it's still falling. So let's add a button so that we can reset the simulation. So as you can see, we are gonna reduce the z vector intensity, and as you can see, we are seeing the point fall and to the infinity. You can also, if you want to stop, you can add a floor. So in the goal points, you can find the floor component and add in the goal objects. Okay, So now it just stops. Hello Vevav. Yeah, you're just 5 minutes late, but don't worry, you can just copy what we have done so far. So, are you guys able to follow along so far? Can you guys write if you're able to follow along or if I'm going too fast? Okay. Okay, perfect. The load component has another input, W. Maybe if you are using the Kangaroo 4 AF Kangaroo previous, the Rhino 5 version, probably that's why. The load component has another input, W. What does it say when you hover the cursor over the W input? I think you have if you have a Kangaroo 1, maybe try Unary, I think they call it. Yeah, Flexhopper is also really nice, and it's even more powerful because it uses a graphics card. Okay, we can even maybe create multiple points, like that, and points. And we connect it there. So as you can see, we have all the points interacting. The Flexhopper, I think I even have it here. Yeah, this is the Flexhopper, but we will see maybe in future if a lot of people are interested. Okay, so let's move on. So now we are going to create a curve. We are going to create a curve like that. Let's turn this off. Import the curve. And let's divide the curve. Maybe like that. Okay. So we have the curve and we have divided it. Let's create the same unary force. First bring down the solver, add the button, load. The points are these. Let's copy the vector and it's falling. Perfect. So if we don't want the endpoints to fall, we have to create an anchor like the ship anchor. So when you go here to goal points, you can find the anchor component. Okay. And how can we find the endpoint of the curve? By bringing the endpoint component. So it gives us Vaibhav, you can I will send the link and you can watch it again, so don't worry, just follow from where you can. So we are gonna create the anchor points, the starting and the end point as the anchor point, and connect it to the goal objects. So if you see, except the last 2 points, like the starting and the end point, everything else is falling down. Also, don't forget to flatten in goal objects, because sometimes it might give you a lot of problem if the data structure is in different hierarchy. So what we are going to do is we're going to create a spring. So what is a spring? So a spring is basically, you have a curve with the distance d, and we can tell Kangaroo if we want the distance d to remain the same or to make it longer or make it shorter. Okay, so to do that we have to go here in lines and bring down the length component. Okay. So each point, there is a line between each point. Okay, and we want to simulate it depending upon the distance. So we have to shatter the original curve into small segments. So let's bring down the shatter component. What do we want to shatter? The curve. And what are the parameters? So we want to shatter them exactly where the points are. So we are going to use the parameters value from divide curve and connect it to segments. Perfect. So we have 17 line segments. So these are our lines, and let's connect it to the solver. There you go. So now we are simulating a chord which is fixed into 2 points, and it's acting by gravity. Are you guys able to follow along? Can you guys please write if you're able to? I'm following fine, but anchor points doesn't seem to be sticking. Did you use the endpoint component and connected both the points? What is the strength? I mean, it should be like the default value, but you can maybe if it's different. Did you connect and flatten the goal objects? Maybe reset it? Did you reset? That's weird. I think, was this happening in the previous webinar too? I think you had some doubts regarding this. It should work normally. Maybe the Kangaroo version is a buggy. You're saying that the whole curve is just falling down, even the last 2 points. Maybe which component are you using, the anchor or the anchor XYZ, or plastic anchor maybe? In the line component, you have to connect the shattered curves, not the original curve. Okay, thanks. So let's if everyone else were able to do it, let's go to the next exercise, which is collision. So for example, let's create 2 points and import the points. Bring the Kangaroo solver. Make sure the previous Kangaroo bouncy solvers are turned off, because it might create problem if more than one is simultaneously running. Okay, so we start by importing the points. Let's go to goals collision and import the sphere collide. So we add the point, and let's add this as the goal object. Let's connect a button. Okay, the radius right now is 1, so let's create a circle just to visualize what is happening. So let's say maybe radius is 2 and the 2. Okay, so when I move this point closer, oops, yeah, so I have to this will be later, the vertex. Yeah, so if I move the point and reset, they are reacting according to the distance. If it gets inside the influence circle, they both collide and they separate. So I think it's better if we use a lot of points. Maybe let's start with populate 2D. So we have a lot of points. Let's connect them all and reduce the the radius to maybe something between 0.001 to maybe 2. Let's reset, hide everything else. So as you can see, when we start increasing the radius, they start to collide with each other and adapt. Okay, sure. Don't worry, no problem. There is no rush. I'm also a bit sick, so I think we all have excuses today. So what we are basically doing is creating a sphere around these points with the given radius, and once the two spheres they are about to collide, they move, they expand, but they cannot collide with each other. So that's why it gives the circle after the solver is to visualize how it's interacting. It's not necessary. So let's say if I turn this on and turn off the circle, we can see it, but it's not the same as before. But when you turn on the circle, you can see how it's affecting. So each step, as you can see, they are colliding with each other. And as it works, like as it is working dynamically, so if you have like a higher radius and you reset, it just pushes it. So if you have even higher radius and you reset, it's just gonna like repel each other with force. Yes, the circle packing algorithm is basically this one. So let's see if we change. Like that. You have to make sure that the radius is not really high and you gradually increase the radius size. Yeah, that's why I started with the radius of 0.001, like a really small radius, and then I gradually increase the radius size. So let's reset, and in my case radius of 0.4 or 0.5 is working, and when you start increasing it slowly you can see the interaction. And not just that, like if we have a predefined radius, and let's start with 2 radius and only 3 points, we can increase the points and the rest of the points will adapt accordingly. So I think this could be interesting in simulating how the cells divide and form like in biology, and you can create really interesting structures because you can control the radius of each point individually and maybe create attractor points and create really cool complex data manipulation sketch. So this could be really interesting. I would also explore if I can do something with this. Okay, perfect. We would go even a level further, where what we're gonna do is, let's see, there must be in the mesh, in triangulation, you have maybe convex Delaunay mesh, maybe, wait, no, maybe this points. Yeah, so like this is the connectivity between each of the points. If you use Delaunay edges, it's in mesh, Delaunay edges. Are you guys able to find it? So what we are going to do is we're going to create something similar like the previous one. We are going to create a spring in Kangaroo. We're going to create a spring. These are the connectivity, sorry, the edges. and connect it to the goal, flatten it. I will hide these. So I will hide even this. So right now what's happening is this component has a strength of 10 and this has a strength of 1. So what does it mean? This means that this component is 10 times stronger than this one, so it will overwrite its effects. How? So let's see, if this is turned off and we start increasing, they expand freely, okay? But if this is turned on and we try to increase the radius, they are held together by these invisible lines, so they are not changing so much their position. But if we increase the strength of the sphere, the collision by 20, now it's gonna override this effect. So this is interesting, and you can create really cool interactions between the spheres. Now it looks like a microscope, like how the organisms they interact. Whoop, whoop. Yeah, they are clustering together. And I think in architecture you can maybe create some cool data-based structures. Yeah, the bouncy step is actually, that's why the bouncy solver, because if you use the zombie solver, what it does is it basically gives you the end result after, in this case, 50,000 iterations. So like when you connect it, so this is the final result, that's it. And whenever you change, it changes and it gives you the final result. It's not the each step it counts. The bouncy and the regular solver are almost the same. Okay, so this is clear to you guys, this exercise. We can even create like the length here. Okay, sorry, let's see another thing. The length here is the length of the edges, so we measure the length of the edge, so that is the original length. But we can even multiply the length by a certain number and change the interaction. So let's say we can multiply it by something from 0.001 to twice. What does it mean? It means that when we multiply the length by 1, it's gonna be the same. But if we increase the length, we are telling the solver to make this curve twice as long as it is. Doubts so far? Mind blown. Okay, perfect. Sorry. So let's move to the next exercise. In this one, we will do the reaction diffusion. So if you want, you can copy. Well, now let's start from scratch. Let's import the bouncy solver. Let's add a button. Reset. Okay. And let's draw a curve. Let's divide the curve by a big number, maybe 500. And let's start with the sphere collide. So these are all our points. Right now, the distance between each point is, like from here to here, it's 0.65 millimeters. So let's say 0.001 to maybe 10. So we can change the number from 0.001 till 10. So I'm going to connect it to the radius. Maybe leave it somewhere like that and connect to the goal. So it's just flying. Perfect. Are you guys able to follow along so far? We are creating same as before. We have a curve. We shattered it into maybe some points. And then we are creating a sphere collide. Oh, sorry, the video is lagging. Is it? I think it should not, but I will turn off extra things. Okay, it's okay now. Sorry, maybe when it's calculating, might be happening. So we have a curve. We shattered it with some points, and we have the sphere collide. And when you see the solver component, it outputs the vertices in the V section. So let's create an interpolate of curves, and we will hide everything. So once you start increasing this point and this radius, you will start to notice how it's changing the curve. I'm gonna make it max, maybe 2. Okay. Okay. But what's happening right now is the points, they are just going away, and there is nothing that is holding them together. So we are gonna do something similar like the circle packing. So what we're gonna do is we're gonna first shatter the original curve using the divide parameters. So we have shattered the curves into 180 line segments, and we are gonna connect the length so that the distance between them remains the same, and the algorithm will try to adapt everything accordingly. Connect to the spring, let's flatten it, and voila. So we are seeing some weird effects, maybe like a worm. But this is not the actual reaction diffusion, because even though the points, they want to go away, but the interaction, the curve between them, it's not letting it. So what we have to also do here is simultaneously increase the length of the line. So maybe connect these two together, and let's start increasing it slowly. So right now you can see a bit more the effect of reaction diffusion. I will try with more points, maybe like 500 points or something like that. I'll hide everything else and slowly increase the value. So now you can see they're not crashing with each other, and we get this nature inspired pattern. Are you guys able to follow along so far? Sometimes I even connect a counter. Why your effect is it's not quite the same? Could be, yes, because depending upon how many times you have divided the curve and what's your radius, and if not just that, the size of the curve, the original curve that you have drawn. So there are a lot of factors, but the idea is, first you are dividing the curve, second you are creating an interaction between the points. You are saying that it has a radius, and once the radius that starts to grow, that we are doing it manually here, they interact and they're crashing with each other and try to escape away from each other using the sphere collide. But at the same time, we are using the spring, the length component, to keep them together so that they don't escape away too far. So it's really interesting, the effect, if you don't have the length connected and you just see, so you have the curve and that's it. The length tries to remain the same. But if you also increase the length between them at the same time, you get even higher level of fractals in between them. So I have like this case. In my case, the length is 31 millimeters. Yeah, like for example, see in my case, when I have the 0.001 and I reset, it starts to contract because the original length is really small, and it will continue to contract. As you can see, it's still getting smaller and smaller and smaller. So maybe give it a higher radius value. Try with maybe 2, 3, 4, 10, something like that. So it's contracting because we are saying that the length between each point should be 0.001, which is really small than the original curve, and that's why they are contracting. And if you give it more, then they're going to expand. So that's how we create this effect. Yeah, exactly. When you put the 0, it's what we are saying to the algorithm is make the distance between 2 points 0. Yeah. And if you don't have anything in radius, what will happen is they are gonna like contract everything to 1 point. So as soon as you put the radius, they are trying to contract, but at the same time the radius, it doesn't allow them to go even further. And you can even control that by manipulating the strength of the component. Okay. Sometimes I even use the record, but before connecting I'll just record limit to maybe 10. So you can see the movements, like how it's evolving. That's a bit trippy, but So I coded a pixel-based reaction diffusion algorithm over the holidays, and the mechanism seems completely different. Yeah, sorry, my mistake. This is not reaction diffusion. Actually, it's a more like a growth simulation. How can we set a limit to the direction in which it is expanding? If you want to limit where it can expand, so we can do is another process, which is using a mesh. Yeah, I mean, computationally maybe they are still the same. So going back to Heba, we have let's draw a surface and go back to shaded. Let's draw a surface. I'm gonna turn off this for now. Let's convert this into mesh. So we have a mesh. Let's import the mesh. Yeah, Mikolaj, yes, you can do that, but make sure that you save everything, because Kangaroo, it might crash when you're trying to continuously loft 10 surfaces at the same time, 10 curves, they're interpolate curves. So make sure you save it properly and then do the loft, so that if it crashes, you can at least get back where you were. The best thing will be stop the simulation and then do the loft, bake it, and then go back. So yeah, I import this mesh. Okay. And here there is a component in goal on mesh, which means is whenever we have a simulation, the simulation will try to keep the points inside the mesh, on top of the mesh. So let's import on mesh component. So what are the points? These are the points. What is the mesh? This is the mesh. And let's connect it to the goal. So turn this off. I'll just turn on the normal curve. And as you can see now, it won't go outside of the given area. So far so good. Oops. Custom preview, I'll just clear it. So as you start growing it, so in this way, when I was working on a project related to this project, I tried to do something similar, which was to integrate maximum surface area possible in minimum area, total area. Questions? Can we anchor it to one direction? Are you asking if you can just make it move in one direction? Yeah, I think maybe anchor XYZ, and you can just anchor the point in, true, false, boolean, toggle. So let's say if we don't want it to go to the X, so we're just gonna say true, false, false, and let's connect it to the, so it will just go in the Y direction and it won't move in the Z direction, sorry, X direction. How did I create the square? It's another square, it's a mesh. So you can either create the mesh here, or you can create a rectangular surface. You create a rectangular surface, and you say brep. You convert it into mesh, and this is the mesh. Makes sense? You can do the other way. You can just make it blocked in one direction, you can make it blocked in another, and you can control everything by the strength factor. So imagine the strength here is maybe 20, and the strength in the line is also 20, but here the strength is 1000, so let's make it maybe 5. So it does go, it does move in the Y, but it's not like permanently locked, it's still flexible. So you can even reduce and make it work like that, but not exactly like that. So it's not precise, obviously. If you want it to precise, you have to make a mathematical model and do it directly. This is more like a simulation. So you have to calculate more or less what works best for you. Questions so far? The good thing about this is, imagine if you have a, let's say if I have the brep, the original brep, this one. I have the original brep, and if I draw a circle, another circle here, and I just cut it using these two, so I don't have anything over there. I'm gonna delete this one for now, and if you reset the algorithm, it will avoid those areas where the mesh is not there. So you can create interesting cool effects. Not just that, I mean, this doesn't have to be 2D. You can we can rebuild, and we can change the orientation of the curvature of the surface, and it still works. So when I increase, it is expanding, but on the surface. I'm just gonna move it a bit to the top, move, so that you can visualize it properly by 0.5 or something like that, maybe less than that, somewhere there, yeah. And maybe connect it to this one. So let's say, so we have even less. Okay, so what happens right now is our original curve is this one, Okay. How did you create this square? Okay, perfect. So the original curve is this one. So what happens is when you start the simulation and the surface is not at the same height as the curve, it will start like bah. So it will hit it really hard. So a better way to do will be projecting this curve on the surface so that it doesn't do this. Like if you see it closely, wait, I'm just gonna turn off this one and just see this one. So what's happening is it's like hitting the surface really hard, and it disturbs the algorithm. So the better way to do it will be projecting the original curve, which is this one, projecting this curve on this surface. How do we do that? We use the project component. This is the curve, and this is the brep, and that is the original curve, and that is this curve. And now if you do it, it's gonna be better. So as you can see, it's a lot better now, because we are starting on the surface itself, and we are not like first hitting the surface really hard and then doing the reaction diffusion. Right now we are changing the radius using a number slider, which is not the best way to do it. So if you guys remember the Anemone plugin, or if you have a Firefly plugin installed, we can use the counter. So let's do it first with the Firefly plugin. So the steps are gonna be maybe 0.002 or something like that, and it's gonna give us a number, and we are gonna create a timer so that it updates every 20 milliseconds. Every 20 milliseconds, yeah, maybe even less than 0.0005 or something like that. So that, and a button to reset. Sorry, I'm just gonna do it and then explain it to you. So we have created a timer which is increasing, and basically what we are gonna do is connect it to the radius. So we are gonna connect it to the radius. So when we reset, I'm gonna turn off the data recorder. So what it's basically gonna do is so it's slowly increasing, as you can see, and it can give pretty cool results. Yeah, the radius, it doesn't have to increase really. You cannot increase the radius drastically, or else it will override and it will like cross, and the algorithm won't be able to figure it out, because it's not the continuous curve. We are talking about point with a circle and then distance between each point. It doesn't have the idea that it's overlapping or not. So as you can see, now it works a bit better. So as you can see, it's working like that. If you're into architecture, or not just architecture but product design, and you want to create growth patterns, so you can do something like this. And let's maybe bake it. Let's bake it. So I have baked that. I'm gonna turn Boolean split toggle. I'm gonna pause the simulation, maybe turn off it. Okay, why is it lagging so much? Maybe because I'm live streaming. And I'm gonna copy the surface and the curve, and I'm gonna split this surface using this curve. So I'm gonna split the surface in this curve. So as you can see, you can make like what? I think it has split like in a lot of parts, but you get the idea. You can make interesting stuff and structures like those. Guillaume, are you not able to do the simulation so far, or is it still giving you problems? Do you guys have Firefly? For your filter project, which one are you talking about? Are you talking about this one? Are you talking about this one, like the plate one, or are you talking about the 3D printed version? How would you turn into this kind of 3D surface like you did with your tiles? I did not get what are you trying to say. How seeing you, how would you turn this into the kind of 3D surface like you did but with your tiles? With this you're saying, well, there are a lot of ways that you can do it. The tile, it's basically this, but if you do it in a different way in mesh and then use cut move Clark to make it organic, you can do that way. So we can see it later, like not in the webinar but in future. Second one, no, in the Regis there was no, it was just basic. It's really basic. It was a given area and then a curve, a closed curve, and then it started to grow. That's it. I just gave the radius of what a 3D printer is most likely capable of printing without failing, so that the curves are really not close, and that's it. I just had a limited area, and then it was really simple. It might look complicated, but it was really simple. And then you extrude it, and then you 3D print it. Okay, so I think we can move to the next. Were you guys able to do this exercise or not? Can you please write it down if you were able to do it or not, and then we can see. I don't have access to the 3D printer from a school. It's from one of my collaborators. He owns a 3D printer, ceramic 3D printer by Delta. It's not really expensive. Like if you are really into, it's around 3,000 euros. But I mean, it's expensive. But if you are working a lot in it, you can recover the sum pretty easily. So Delta Wasp ceramic. So this is the 3D printer. It comes with the ceramic kit, and you can 3D print in ceramics. No, I just the converting this into 3D was basically really simple. What I did was, first I baked the curve. With the curve and the surface on top view, what I did was I split the surface using the Rhino command split. Select the object to split. Using the curve, I splitted the surface. Now I have a lot of surfaces like this, like jigsaw, sorry. And then I extrude it. You can do it by surface extrude, solid extrude surface, or you can just, in the Rhino 6, when you select a surface and you hold the circle, like this circle, not this one, this will just take it up. When you hold the circle and stretch, it actually extrudes the thing. Sure, no problem. Okay, let's go to the next exercise. We are already like really tight with the time, but let's move on. Turn off everything. The thing about Firefly is just basically creating a timer. You can use anemone. You can create a loop of 0.001 adds with 0.001, and then you loop it maybe 1,000,000 times, and each time it loops, it gives you a small increment in number, and you can use it to control the radius and the length of the spring, and then make the structure grow slowly. And you can change the amount by how fast you want it to grow. So you have to calibrate it according to the use. There is no like one correct answer for that. Okay, perfect. I mean, there are a lot of things that I wanted to see in the webinar, like we have done that. This one is from what we are going to do. There is a okay, well, we can do this together. Let's do it. So to start, let's start by bringing the Kangaroo solver canvas. You guys following along, or are you guys bored? Let's go to mesh tool and create a mesh plane. Or if you don't want to do that, just create a surface on top view. Surface. Select one surface. I'm just gonna center it, but no, it's not. And we are gonna, yeah, this is joking, but still, you guys have to be a bit active, because this is really one-way communication, and it's really I'm not sure if you guys are following along, or if I'm going really fast, or shall I do less exercise but in details. This is more about like seeing a lot of things, and then on your own you then later learn online and do courses. So we're gonna go and see a lot of exercises. So let's create a surface, import a surface, and then create a mesh from surface by 10 by 10 maybe. Okay, and in this one we're gonna go to goal mesh. Try to here, I don't want, okay, sorry, yeah, perfect. Let's go to goal mesh. First we created a surface in Rhino, imported it in Grasshopper. Then using mesh surface, we are converting this surface into mesh, 10 and 10 subdivided into X and Y, and U and V. And now we are going to go to goal mesh, and then connect the vertex load. Okay, so this is the mesh and this is the load. Connect a button to reset it, and the strength, maybe let's give something between 1 to 5. We don't want it to be really strong, so 0.001 is like perfect for me. And there is another one to make sure that the dimensions between the edges are not changing. So which is in a curve, which is the length, in a mesh this is gonna be edge length. So let's import the edge length. This is the mesh. The length factor is 1, which means this is gonna remain the same. If it's 1, if it's 0.5, it's gonna be half. If it's 0, it's gonna be 0. It's gonna, if you put it 2, it's gonna be twice the length. So let's maybe put some values between from 0.001 to 2 maybe, and then connect this also to the goal objects, flatten it, and then so if we have a lot of are you guys able to follow along? So we are converting, we are doing basically what we did with the curve, but now in a 2D scale using a mesh. It's basically the same. We can do the same what we did before, but instead of doing it with every point and every curve, they have already built-in components for mesh. Okay. As you can see, we are not able to see the mesh. So there is a component called show, which basically means that it's going to visualize the mesh in the Grasshopper. This is here, you can find it. It's not important, but if you want to visualize what's happening, you can do that. Okay. But we don't want it to go away like it's going now. We want it to remain like at least the edges on the floor. So here in the mesh manipulation tab, you can find the mesh corner component. So what it does basically is it takes the mesh and then gives us the 4 vertices. We cannot connect it here because this is not a Kangaroo component, the Kangaroo output. We have to create anchors using these 4 points. The same as before, we create an anchor, the point, and that's gonna be it. So we have the 1 length factor and then maybe give it more strength. So there we go. Let's create a mesh container and in the object connect it there and maybe hide this one so that we only see the mesh. Okay. It's lagging, but I think why. So as you can see, if we fix all the 4 edges, it's acting this way. We can even maybe connect the mesh, hide this one, maybe thicken it using Beaver Bird. give it a distance. Okay. And are you able to follow along so far? So let's maybe just make it attached only on the 2 points. So we can do list item. So if we connect just this, it's just gonna be attached to that point. If we add another point, it's gonna be attached to these 2 points. Okay. So far so good. Maybe make it softer. The screen looks blurry. Maybe because I'm using too much resources for the computer. This doesn't happen. I don't know why it's happening today. Maybe my internet connection is not so perfect. I don't think it should be from my end. Yeah, I think it's because when I'm doing a lot of computation, the OBS screen recorder is failing. If you are not able to follow, sorry, you can come back and watch it again. So after this, we can also add another component, which is the wind simulation. If you go in the goal mesh, you can find the wind. Let's draw a curve in the Grasshopper, in the Rhino environment. What is the mesh? This is the mesh. The wind vector, we can directly connect a curve. And this is our wind. Whoops, did you see it's just flying away? Because the curve is giving a really high vector. So we can change that by creating an amplitude. So this is the vector. And we can give an amplitude between 0.001 to 2 maybe. So as I increase it, sorry. Are you guys able to follow along? Can you guys write if you are able to follow along? We are gonna do this exercise and a last one, which is gonna be the collision one, and then that's it for today. So the curve is, this is the curve that you design, and you can change the direction. Like if you change the direction of the curve, you're changing how it should, which direction it should blow the wind. Make sense? Now you can bake and then have the weird looking cloth. And you can even add like the collision in between the mesh points so that they don't overlap with each other. You can't find the mesh corner. It should be here. Is everyone able to find what is the curve you imported? The curve is just a basic curve that I draw in Rhino. You draw a curve, and this is the curve that you import for the wind component. So this curve determines in which direction the wind is gonna blow. And to control the intensity, we have multiplied it by amplitude. So the higher it is, the stronger the wind is gonna be. And the lower it is, the slower the wind's gonna be. And you can change the direction by changing the orientation of the curve. I got lost. Are you able to find the mesh corner function, or you're still unable to find it? If not, then maybe you can try naked vertices. And then from that naked vertices, find the edges. Or if you don't find, you can just directly deconstruct brep, and you can use these vertices, these 4 vertices as the anchor points. Is the same. Okay, you don't need the mesh. I mean, this is a really simple geometry, that's why. But if you have a complex geometry, the mesh corner might be really helpful. Okay, perfect. I'm gonna turn off this definition, and then let's move to the last exercise. So we start by creating a cube. Let's create a cube. Let's copy and paste and scale it a bit down like that, and do a difference boolean so that we have like a holder, because we are gonna do this exercise, this one. Okay, so let's start by importing the Kangaroo solver, connect a button in the reset tab, and flatten the object already. And we are going to import a brep. We can even import a mesh, but we have a brep. Sorry. And we are going to import a component called solid point collide. So this is our solid. Can you create the box one more time? This box. So you start by creating a cube. You then copy and paste the same cube and scale it down, and then move it up so that you can create a difference boolean using this cube as the cutting object, and you have the geometry. Okay, and on the top view we are going to create a surface like that, maybe, and take it like somewhere here. Let's import the surface and use the populate geometry component. So we have maybe 50 points. So those are our points, and this is our brep. So let's connect those two and connect in the goal. Okay, So as you can see, nothing is happening. That's because the points are where they are. So to do the to make the points fall, we are going to connect it to load point in the z direction by negative 1.000 to positive 1. And this is also our, so let's change it so that it doesn't fall so drastically. Okay. So far so good. Okay, so what's happening is that those points are falling to infinity. We can even add a floor so that they don't fall below the certain level. So this is how you can create like physical collision interaction between points. And as you can do this with point, you can even do this with mesh, because meshes are made out of curves and curves are made out of points. So you get the idea. You can combine different techniques and make like a cloth drape over this geometry. You can create maybe a sphere using the mesh sphere. Make sure it's mesh sphere and not the nerves one, because it's gonna be really heavy. So make mesh sphere and connect it to the vertices. The radius is gonna be something maybe like that, 2.5. And custom preview. And we are gonna move the points in the z direction by the same amount as radius, so that it doesn't create the sphere at the point, but at the center of the sphere where we want it to be. It's just a visualization thing, nothing more. Don't worry about it. And not just that, for example, here as you can see they are colliding, but if you add here the sphere collision, you can create even more interactions. So right now the radius is 0.1. Make the radius same as this, and there you go. So they are now interacting with each other also. Make sense? Yeah, exactly what you asked. Are you guys able to follow along? Doubts? It's like a bouncy ball pit. Yep, got it, thanks. Perfect. Okay, I think we are gonna be doing more or less about that. We looked at how to create like a thread-like structure. This is in the first webinar if you want to look how we did it, but it's basically we have it already here, like almost in this exercise. So here you don't have the wind thing. We delete the wind thing. We have the mesh. In the mesh, in the final mesh, we can create the frames. And this is our mesh that we want to thicken. And then, so yeah, more or less we have it like that. You bake it. So yeah, this is cool, perfect. All right, so going back to the presentation, we saw this, we saw the wind simulation also. We saw the collision, the sphere collision. We even saw how to create the growth simulation using curve on a morphed surface. Gabby Garcia, yeah, your points are going downwards because you didn't add the floor component. So if you see this one, we added the floor, which you can find here, so that it doesn't go to infinity, because if we don't have it, they're just gonna go down and down. Okay. Okay, so add plugin into Google Objects. Okay, yeah. Do you have a floor? No, it's not like a physical floor, a geometry that you create. It's just a component that at the 0, 0, 0 level, it creates a floor automatically, like an infinite floor. So books for recommendation, I'm reading right now this book, The Meme Machine. It's really interesting. Yeah, that's it for today. Sorry, I'm not the best. I don't know what's the best way to end up. If you have any doubts, just keep writing. We can still discuss about it. So going back to the book recommendation, I've been reading this book and this is really interesting. And there is also a podcast that I can share it in the Instagram, and you can find out about it. And this is really a crazy idea, because what they are saying is the ideas that we have, the cultural ideas about design and about everything basically, is also an evolutionary process, and they are fighting for survival as equal as a gene. So let's say there is a new internet meme and it's fighting for space in your head and competing with other memes because it has a really limited resource in your head to occupy. So it's a really weird idea, but it's really interesting because it can help you understanding why people like certain types of designs, forms, colors, and could be a really interesting way if you can implement some of the findings from the research that they show here into your design work. So let's see. Probably doesn't want. Yeah, the word meme was coined by Richard Dawkins in 1970s, and it has become famous right now because of the internet meme. But no, this is not about the internet meme. It's a different. Well, it is there, but internet meme is being really narrow. It's more about the concept of pneumatics. Please fill out the form if you haven't. I'm gonna put it in the chat. So it's basically a form where you can give me feedback about this webinar, and if you have any suggestions, if you want to learn any special kind of plugin, so let me know. You can, yeah, I mean, the website is there, but I haven't updated it much. I hope to add new projects, but stay tuned in the Grasshopper tab where you can register for the next webinar, and you can download examples from the Gumroad page. I will try to upload more examples over there, but for now you can play with these three. And yeah, that's it for today. I mean, if you guys have any more questions, you can write it in the live chat section. Write me on Instagram if you want to. Also, I have a request this time. I forgot the last time. If you guys can share in the story about this webinar, like if you learned something, or if you found out some interesting stuff, or how you might use it, or some extract of what we did, so that more people can know about this webinar, and this could be even more fun the more people are there. Okay, that's it for today. I hope this was a helpful webinar session. Yeah, sure, play around, let me know, just tag and I will also repost. Connect Grasshopper to some other 3D software, example Blender. Yes, there are a lot of ways to connect different oh wow, is the webinar lagging? I think the webinar was lagging. Is it back to normal? I think so, yeah. Okay. Okay, yeah, sorry for that. Yes, there are ways to work with Grasshopper using different 3D softwares. They're not gonna be always a really easy way to do it, but there are plugins that can help you make this connection. For example, with Blender, I haven't tried and I have no idea, but I'm pretty sure if you write to me on Instagram, I will point to some web pages where they are able to do it. You can use Lunchbox, for example. There is a plugin called Lunchbox, and here you can import and export data from Excel, like Microsoft Excel. And I was able to connect SolidWorks with Grasshopper, and you can do like a lot of crazy stuff using the Excel sheets. You can even use Galapagos and evolutionary algorithms on SolidWorks being here on Grasshopper. There is also one for Illustrator, Grasshopper, called Doodlebug. I think it was called Doodlebug, yeah. It was also really interesting, and then like that. Yeah, so as you can see here, you are able to draw in real time the drawings in Illustrator using Grasshopper. So there are really crazy stuff you can do with Grasshopper. Maybe we can I will write it to you. Just write me on Instagram, please. Check out Enscape for the rendering. Yep, that's also interesting. Yeah, Primer, I follow him. It's really interesting because I think he uses Unity to simulate evolutionary behaviors. Primer, I think so. Yeah, this one. It's really interesting. Yes, really cool YouTube channel if you're into evolutionary algorithms and computational biology. This channel is really interesting. There's another one which is Amoeba Sisters. They are also really good with biology and explaining stuff. Okay, I think that's gonna be it for today. Please fill in the forms, webinar forms. Do share if you liked the webinar on Instagram, and also if you want you can subscribe. I don't know if it makes sense, but you can subscribe my YouTube channel here. But I'm gonna be sending you emails eventually, so as you wish. And that's it. And we will see in 2 weeks. Just write what kind of plugins that you would like to see in the next webinar session, and we will see what we can do with it. Okay, good luck with your design projects, and all the best. Bye bye.